Lesson 3 is going to be about dividing polynomials. So when you divide a polynomial, it allows you to see whether or not something is a factor of a polynomial. Dividing polynomials, guys, at the end of the day is no different than dividing numbers. The first type of division we're going to look at is long division. It is the most complicated one. However, it can be used to divide any polynomial, okay? So it always works. All right, there's no rules. There's like no special rules to it besides this one. But again, y'all have already worked on long division with numbers in elementary and middle school. So we're going to use the same approach. We're going to divide until the degree of the divisor. So what's on the inside, or excuse me, we're going to divide until the degree of the divisor is bigger than the dividend. So we're going to go until what's on the outside's degree is bigger than what's on the inside. Remember, just a couple quick examples here. 78 divided by 3. So 78 on the inside, 3 on outside. We would figure out how many times this outside number would have to, or how many times it could go into 7 without being bigger, which was 2. And then we would multiply, so 2 times 3 is 6. Then subtract, bring down. And then how many times can 3 go into 18? 6, 18, 0, and we're done. Okay. 29 into 13, or 13 into 29. 13, 29. So here we would see how many times what's on the outside can go into the first digit. We can't, so we would write a 0. Then we would do the next one, so 9. It's 2, and then 2 times 13 is 26. 3. And because what's on the outside is bigger than what's left over here on the inside, we would stop. Right, there's nothing to bring down. We could do decimals, but we're not going to do that here. So this will be 2 remainder 3, or it will be 2 plus 3 over 13. All right, so the R, your remainder, is going to become a plus sign, and then 3, what's left over your remainder, divided by what's on the outside. And what this does is when we go back and do multiplication or test our work, we have 2 over 1 plus 3 over 13. Right, multiply top and bottom by 13. Be 26 over 13 plus 3 over 13 is equal to 29 over 13, which is what we started with, so we know it's right. Now, an example of a polynomial is what's on the, so 2x plus 1 2x cubed plus, now here's extremely important, I have a 3, I have a 1, I have a 0, I'm missing the degree of 2. So because I'm missing the degree of 2, I have to write in 0x squared plus 4x minus 9. Okay. And now what times 2x is 2x cubed? Well, it's just going to be x squared So x squared times all of this on the outside will be 2x cubed plus x squared. I subtract. 2x cubed minus 2x cubed is going to cancel. Every time you do the subtraction, your leading term should cancel out. All right, and then 0 minus 1 will be negative x squared. We then bring down the next term. And then what times 2x is x squared. Should be minus 1/2 x. All right, and then when I multiply it, comes negative x squared minus 1/2 x. Subtract. These cancel. I'm left with 9/2 x. Now bring down the 9. And then what times 2x is 9/2 x. So 2 times what equals 9/2. Divide this by 2. So that'll be 9/4. Which is really 9/2, or 9x over 2. Plus 9/4. These cancel. Negative 9 is really 36 over 4. 36, or excuse me, negative 36 plus negative 9 is negative 45 over 4. This is now my constant, or what's my remainder. And it's over 2x plus 1. Again, what you can do here is use Desmos, type in your answer choices, type in what you're given to verify that your answer is or is not correct. Right, because division is still a form of operations. Okay. So again, I'll do one more of these. I'm going to do number 5. Now, very important here. So I like to find my degrees. All right, and that's going to be where my exponents are. So this is really a 1. This is a 0. So I have 2, 1, 0. Make sure you write this in the correct way. I wanted to give you at least one example like this because, you know, test makers could possibly do this to you. I don't agree with it, but it's a possibility. All right, so what times x is x squared is just x. So it'll be x squared plus x. Again, your leading term should always cancel. Negative 9 would be negative 10x. All right, bring down to minus 10. What times x is negative 10? Minus 10. All right, these cancel. -10 plus plus is 0. So my answer is just x minus 10. I'll show you really quick what I meant. All right, so you type in what you're given and y equals. So -9x plus x squared minus 10 over x plus 1. And then my answer was y equals x plus, x minus 10. And then you can see the red and the blue overlap. All right. So again, division is a type of operation, and we learned back in Unit 1 that anytime you see add, subtract, multiply, divide, right, finding the equivalent forms, simplifying, right, that you can do graphs overlap. Division is just another way of simplifying. It's another operation. So try and do them by hand, but you can also go back and verify your work by graphs overlap and Desmos.